On example 3, notice when I add them up, they don't cancel. So what I'm going to do, but I notice I still have these two variables, or these two coefficients are the same. I'm going to multiply one of my equations by -1. You're essentially subtracting the second equation. But I would say let's write it multiplied by -1. So my first equation, I'm going to, right here, I'm going to say 3x plus 6y equals 30. And then my second equation is -5x minus 6y equals -6. Now add them, because notice my y's reduce. So 3x minus 5x, well, that's -2x. 30 minus 6 is 24. I'll divide both sides by -2. X equals -12. Now, we are going to be substituting x into one of our equations. And I like the first one. It doesn't matter which one you use. So I'm going to replace x with -12 plus 6y equals 30. So 3 times -12 is -36 plus 6y equals 30. We're going to add 36 to both sides. 6y equals 66. Divide by 6. Y is 11. So we'll say -12 and 11 is our solution. Sometimes it's not solving the system that's hard. Sometimes it's writing the equation for your system. So let's take a look at here. We have Javier and Mason. They build computer parts and sell them to make a profit. Javier can build a computer in 0.9 hours. Mason can build one in 1.2 hours. So Javier is a better worker. He gets more production out. During a typical week, Javier and Mason can spend a total of 15 hours building the computers. One week, Javier builds twice as many computers, and the two spend a total of 24 hours. So in other words, Javier builds twice as many computers, but it takes him longer because he builds twice as many computers. His rate doesn't change. How many computers do Javier and Mason each make during a typical week? So we're going to write our let statements. So we're going to let X be the number of computers Javier makes. And we'll let Y be the number of computers Mason makes. We're going to write two equations, one for each week. Let's do the first week. So Javier spends 0.9 hours on our computer, making a computer. Mason spends 1.2 hours making a computer, and together they make 15 computers, or 15 hours. They spend 15 hours, not 15 computers. We're looking for the number of computers. Now, during week 2, Javier makes twice as many computers. So I'll say 2 times 0.9x. Mason continues to work 1.2 computers, 1.2 hours to make each computer, and they spend 24 hours working. Now let's simplify that a little bit. So 2 times 0.9x is 1.8x plus 1.2y equals 24. And I got 0.9x plus 1.2y equals 15. Notice my 1.2, they're the same. They're the same. I want them to be opposite. So what I'm going to do is I'm going to multiply my second equation by -1. So I'm going to say 0.9x plus 1.2y equals 15. -1.8x plus 1.2, try that again, not plus, minus 1.2y equals to -24. Now we can add them up. 0.9 minus 1.8 is -0.9x. My y's, they cancel, don't they? 15 minus 24, well, that's -9, isn't it? So we divide both sides by -0.9. X is 10. In other words, Javier makes 10 computers in a week. Now, let's go back and let's find out how many Mason makes. I'll use my first equation. So I'll say 0.9 times 10 plus 1.2y equals 15. 0.9 times 10 is 9. Let's subtract 9 from both sides. 1.2y equals 6. So I'll divide by 1.2. So 6 divided by 1.2 is what? We get 5. In other words, Javier makes twice as many. So let's answer that question. It's a word problem. Let's not write it as a word problem. Let's answer the question. So Javier makes 10 computers and Mason makes 5 computers each week. And there we have it.